Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So then these two cancel out, and I get x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now I'm going to rewrite this as x to the power of 3 to the power of 2 minus x minus 1 to the power of 3 to the power of 2 is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this can equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3 is equal to 0. And now if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. And a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So I'm going to rewrite this as x to the power of, x minus 1 times, x plus x minus 1 times x squared minus x minus 1 times x plus x minus 1 squared. And then we have this times x minus 1 times x squared plus x minus 1 times x plus x minus 1 squared. And these two are actually separate equations. So this is equal to 0 and this is equal to 0. So let's first start with this here. So x minus 1, these two x's cancel out. So I'm simply left with positive 1 times x squared plus x squared minus x plus x minus 1 squared. This is equal to x squared minus x plus 1, which is x squared minus 2x plus 1. So we have 3x squared minus 3x plus 1 is equal to 0. And to solve this, we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a, which is equal to 3 plus or minus negative 3 squared is 9 minus 4 times 3 times 1 all over 2 times 3, which is equal to 3 plus or minus the square root of 9 minus 12 over 6, which is equal to 3 plus or minus the square root of negative 3 over 6, which is equal to 3 plus or minus the square root of 3i over 6. So these are my two solutions. Alright, so in this problem, I have 9 to the power of m minus 9 to the power of n is equal to 648. So based on first glance, we can tell that m is greater than n because the result is a positive number and the bases are the same. So 9 to the power of m minus 9 to the power of n, this is a positive number, meaning 9 to the power of m is greater than 9 to the power of n, and m is greater than n. So now that we know this, we can say that m is equal to n plus some number k. And now I'm going to replace m with n plus k. So now I have 9 to the power of n plus k minus 9 to the power of n is equal to 648. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of n plus k, that's going to equal 9 to the power of n times 9 to the power of k. Now I have this minus 9 to the power of n is equal to 648. Now if I factor out 9 to the power of n, I get 9 to the power of n times 9 to the power of k minus 1 is equal to 648. And 648 I can rewrite as 81 times 8. So now I have 9 to the power of n times 9 to the power of k minus 1 is equal to 81 times 8. Now, 9 to the power of any number, that's going to be odd, right? 9 to the power of any number is odd. And 9 to the power of any number is odd, but an odd number minus 1 is going to be an even number. So 9 to the power of n is odd, and 9 to the power of k minus 1, that's going to be even. So 81 is odd, and 8 is even. And notice how we have something in the form a number times another number is equal to another number times another number. And it's an odd number times an even number is equal to an odd number times an even number. Meaning we can set the odd numbers equal to each other and the even numbers equal to each other. So now I have 9 to the power of n is equal to 81, and I have 9 to the power of k minus 1 is equal to 8. So for 9 to the power of n equals 81, n is obviously equal to 2 because 9 to the power of 2 is equal to 81. And for 9 to the power of k minus 1 is equal to 8, this is a simple equation. I'm going to first start by adding 1 on both sides, so I have 9 to the power of k is equal to 9. And 9 to the power of what is equal to itself? 1. So k is equal to 1. Now remember how we set m equal to n plus k, meaning m is equal to n, which is 2, plus k, which is 1, so m is equal to 3. So n is equal to 2, and m is equal to 3. These are my solutions for this equation. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent and b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now, if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 51 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784.